in order to answer this question, we're just going to arbitrarily make up a compound to name. So I'm actually just going to start by drawing a backbone of something. And I'll do a pentane. And what I'm going to do to make some stereocenters is, let's see here. I could put a chlorine at that location. And since this is right here, I could put a bromine right there. And that would give me both these locations as asymmetrical centers. Alright, so if I named them without giving a stereocenter, I would actually have a 3-bromo, 2-chloro, pentane. And now, just to make it so I have something to draw, I'm going to come out here in front, and I'll say I'm going to do a 2R, 3R conformation. So we can actually figure out how to draw these. Alright, now, there are two types of structural drawings we're going to do. One is more of like the perspective drawing with the wedges and dashes, and one of them will be more of a Fisher diagram. Now I'm going to do both of them, and to just distinguish them, I will do the perspective drawing first of all. I think I'll go in blue. Alright, so what I'm going to do on any perspective drawing is I'm going to try to get the backbone almost exactly like you'd expect it to be, so no wedges or dashes. So I really am going to just start this with a staggered with 5 locations. Now where I'm going to end up doing is I'm going to put the bromine at this first, well, that'll be the chlorine and the bromine here. And I'm going to do them with wedges or dashes. Alright, but I need to plan this ahead of time before I go in there. So I'm going to actually start planning on this second location as the first chiral center I'm going to come up with. And I know from priorities wise, that would be my 1 position, this will be 2, and this would be 3. Alright, so I want to be able to go around 1, 2, 3, and when I put that over here, I'm going to put where I'm going to put the chlorine in. I'll come back and either turn that into a wedge or a dash, but I want you to see that no matter what I do right now, I'll change this to a different color for a moment, I would have a rotation that's going counterclockwise. Oh, I'm sorry, that is clockwise. Alright, going clockwise with the hydrogen in the back would be an R rotation. So I do want that chlorine coming out in front, so I'm going to change this back to my dark blue, put that wedge in there, and then I can get rid of that blue line that I've highlighted in there, because that's not part of the actual structure. Alright, going to come back over here now and do the 3 position. It has the bromine in it. I'll change ink color so I got different numbers here. I'll say that's going to be my number 1 position. Between these 2 carbons tying out, the carbon with a chlorine in it would give me our 2 position, giving this a 3. So again, back over here, when I have that bromine added, going to be here, we're going to have a rotation that most definitely goes from our 1 to the 2 to the 3. That is also clockwise, so in this case I want both the chlorine and the bromine coming out at me. And then we can erase that little light blue part. Now that's the strategy I always use. I try to keep the backbone nothing but carbons, and then I place the substituents either coming out of the paper or going into the paper, and in a manner that I need them to make the rotations go the way they go. Alright, but when I do a Fisher diagram, this is going to get changed ever so slightly, and that's mainly because the Fisher diagram doesn't show any wedges. Now, I am only going to have 2 crosses because we only show intersections on a Fisher diagram for the 2 stereocenters. And generally speaking, when we have a choice, we'll put our first carbon up top, or the one that has the most oxygens on it, and I don't have a situation like that, so I am going to put the CH3 on top. Then at the bottom is going to be that CH2, CH3. So if I were numbering the positions, 1, 2, 3, 4, 5, That is 1 here, 2, 3, 4, 5. Alright, turns out though the fissures are a little bit easier to draw, because what we're going to do to make sure we have our R and our S is just choose which side gets the chlorine and bromine. Now this will be backwards, so when I actually do my rotations here, I'm going to actually, I want these to be counterclockwise to show an S, or to show an R configuration, because fissure diagrams are backwards from that. Alright, so that first location we had our chlorine was definitely number 1, the lower carbon was 2, and the upper carbon was 3. And we want to go, if we think about it, this would represent our 2 and coming up here to 3. We want to go counterclockwise. I'm going backwards there. So we want to go from 2, or from 2 to 3 in a counterclockwise way. So we would need to do from 1, I shouldn't do that there, from 1, 2, all the way up to 3. And that gives us our counterclockwise. Therefore, chlorine is right here. And now we can get rid of that light blue line, and we'll do the same thing for the bromine. Another way you might do this, let's just arbitrarily put the bromine on here. Think maybe, okay, maybe it's on both sides. Well, if the bromine is there, our rotation would go from 1 to 2 to 3. And if you look at that, that is actually clockwise. We don't want it to be clockwise because this is another this is another R location. We want it to be counterclockwise, and we'll fix that really quick by putting the bromine over here instead. And with it over there, our rotation is from 1 to 2 to 3, counterclockwise. Now, I'll be honest, best way to get good at these things is to actually just practice. Maybe take something like this, reverse those numbers around, and see what you can get for a drawing. And just practice it. And then what you can do to check it, is should be able to, we can go to Marvin. This is the program we were introducing in lab. Just do Marvin JS. And something cool we can do, and it should work on your home computer just fine. Go here up under import and change this to a name. And what I'm going to do is actually put that name right in there. So with the R's and the S's and all those wonderful things. So it's going to be 2R, 3R, and then that was 3 bromo, 2 chloro, pentane, and then I hit add, and well, it did it kind of opposite. I got the chlorines and bromines both going into the paper, so think about they basically just flipped that around 180 degrees, so like grabbing this in and pulling it up towards you and putting it down, that would have put the bromine and the chlorine into the paper, and then they just ever so slightly rotated it. But we can use this to check ourselves, and I probably can make that actually, will that fix that? Yeah. So I just rotated it into the paper to get that. I can rotate this again by selecting it and then grabbing that, make it to 90 degrees. And I think that matches exactly what we kind of drew. Almost. I got it upside down again. But Marvin's a good way to check yourself, see if you're coming up with the right stuff. And it does do the stereochemistry just fine. And if you want to change one of these, mess around with it, and then pop that in there. And if you want to see if you can name it and then see what Marvin comes up with, go here to the export and click on, for the format, change it back to name, and it will actually name it. And technically, since I just changed that one position, that will just change one of those two. And that's a good way to actually practice to make sure you're doing these things right. All right. Good luck with all that. It is just a matter of practicing.